Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Education, SOE, Certificate Programs Certificate in Elementary Teacher Education, for Tripura State, CETE, Optional Courses, MESE, 01 to Teaching of Science, Block-1 Instructional Planning and Evaluation in Science, Unit-4 Evaluation of Learners' Progress, 4.1 Introduction. After deciding what should one teach in science, i.e. the content, facts, concepts, theories, principles, laws, formulae and processes etc., and how one should teach, i.e. the method, the next step in the teaching learning process is how to evaluate what has been learned by the children, i.e. the evaluation process. It is general feeling that evaluation is examination. One cannot deny the use of examination. If we analyze the examination questions, we find that mostly knowledge-based Q-questions are scared, and very little emphasis is given to comprehension-based, application-based, analysis-based, synthesis-based, and evaluation-based questions. Our examination questions should test all the objectives, cognitive, affective as well as psychomotor. Clearly defined objectives help us in effective and objective evaluation. Therefore, we should identify objectives beforehand and state them very clearly. If our objective is just to increase knowledge, we should not ask comprehension, application or skill-based questions, and if our objectives are knowledge, comprehension, application or skill-based, then we should test all the objectives and not just the knowledge, which is usually the case. For e.g., if our objective is to develop the skill of reading a thermometer, one should give a thermometer to the student and ask him to read, instead of teaching the students how will you read a thermometer. Though we identify several objectives, they are just on paper. We try to achieve only those objectives which are usually tested in examination. Examination system will become effective, objective, when it's continuous and comprehensive. It will have a great impact on quality science education to our children. But we should be clear that evaluation is not just examination. It is much more than the examination alone. Evaluation is an integral part of the teaching learning process. In practice, evaluation is used to pass judgments about students' achievement and can also be used for improving students' learning. Evaluation is not only the measurement of students' learning, it is also used for enhancement of students' achievement. For this, it is important that the evaluation should be treated as an inseparable part of the teaching learning process, and evaluation data should be used as a diagnostic device so that proper remedial instruction could be undertaken to improve the students' learning. 4.2 Objectives. After completing this unit, you will be able to distinguish between evaluation and assessment, understand the importance of evaluation and assessment, clarify the concepts of evaluation and assessment, analyze the purposes of evaluation and assessment in science, identify and use the techniques of assessment in science in both theory and practicals, identify and use the prescribed steps in test construction, identify and use the criteria of a good test, identify the weaknesses of the slow learners or the slow average students by diagnostic tests in science, and provide the necessary remedial measures, set a science practical examination. After setting science practical examination paper with I. List of apparatus and chemicals, 2. General instructions for examiners, and 3. Key to the question paper concept and importance of evaluation and assessment. Practically, all our school evaluation activities are limited to the area of scholastic attainment rather than the total growth of the child. This is just a part of the evaluation process, which is called assessment. Assessment is an attempt to measure not the pupil as a whole, nor his worth but some particular abilities like knowledge of science content, skill of handling the apparatus, setting up the experiments, performing the experiments, collecting and analyzing the data, observations, and concluding, etc. Assessment declare the students in a pass, fail category, and also assigning them IST, second or third divisions. Therefore, it is important that it should done objectively, as these divisions and percentage of marks help students to get admission in higher classes. Evaluation, evaluatio tilde L on the other hand, carries a very wide meaning compared to assessment. The term evaluation stands for assessment in all the educational outcomes that are brought about as a result of teaching learning process. Evaluation is used to assess the change in the total behavior of child related with all the domains, cognitive, affective, and psychomotor. Evaluation also assesses the child's progress in science curriculum as well as co-curricular activities like science projects, innovative experiments, science excursions and science fairs, etc. Evaluation has its own imprata. ci.isr.rl L tilde 2r tilde 3 tilde slc tilde psych tilde tilde. Evaluation may ht considered as a comprehensive and continuous system of assessment that may help in knowing whether the extent to which the identified objectives have been achieved and the expected behavioral changes have taken place in the learners in order to set them on the right path of learning. This evaluation may help science teachers to assess their methods of teaching and the school principals in bringing desirable reform 5 in the overall educational and administrative setup. Evaluation thus may work as a bridge connecting the objectives of teaching science and the ways and means of achieving objectives in the forms of learning experience, teaching methods and learning environment, availability of 11 science material needed for experiments and demonstrations and its use of environment and local resources, school clubs, the freedom to work on various science projects, frequent science excursions, etc. 4.3.1 Evaluation and Assessment in Science. Evaluation in science. Evaluation in science assesses all the teaching learning outcomes in terms of overall behavioral changes related to science content, facts, concepts, laws, principles, theories, formulas, etc., and science processes, observing, classifying using numbers, measuring, formulating hypotheses, interpreting data, controlling variables, and experimenting. Not only does evaluation assess the desired science knowledge, but it also assesses its comprehension, application, analysis, synthesis, and evaluation. Evaluation encompasses objectives of all domains, i.e. cognitive domain objectives, affective domain objectives, receiving, attending, responding, valuing, organization, and characterization by a value or value complex, and psychomotor domain objective. Evaluation assesses both the curricular abilities in science and science-based co-curricular abilities in the child. Thus, evaluation has made THC process of testing and assessment as continuous and comprehensive. The purposes of evaluation is therefore to assess the overall development of the child. Assessment in science, as yes meant us, ally measures how much science content, concepts and skill has been achieved by a child out of the identified content which he/she was supposed to achieve in a particular class. This content was generally knowledge, but how state education boards in Class X and 11-1 examination and the progressive schools have started comprehension, understanding, and application-oriented content as well. Assessment will be useful in following ways. 1. Providing feedback to each pupil about her progress in science. 2. Giving feedback to the teacher about the effectiveness of her science teaching. 3. Providing information to prepare individuals for further science education and employment opportunities. 4. Motivating children to develop interest in science. SK the students to answer the questions raised. It may still be difficult for them to answer these questions quickly. Lead the students to realize that they can answer the questions faster if the data are organized in some manner. Since the questions relate to a comparison of its, the best way to organize the data is to write the heights in increasing or decreasing order. We then have the following table, Table 8.2, look at the screen. Having organized the data as shown above, it is now easy to get the information sought. Answering the questions and inferring other results from the organized data comes under the domain of interpretation of data. Thus, statistics are the branch of mathematics dealing with collecting, organizing, and interpreting data. The teacher will do well to tell the students that interpretation of data involves much more than answering simple questions such as those raised above. It includes prediction, testing of assumptions made, etc. Methodology used. Mainly the lecture-cum discussion method is used to discuss the nature of statistics. 4.4 Techniques of assessment. A good assessment program depends upon the appropriate and accurate evidence that we get about pupils' growth. This is possible through the use of various types of quality instruments of assessment. There are a number of tools, instruments, and techniques which can be employed for assessment of pupils in science theory and practical. An assessment tool is an instrument or any device which facilitates assessment work. An assessment tool may be a question paper, science theory or practical, a unit test, or an oral test, viva in science practical. An assessment technique is a process of gathering information or evidence in which one or more than one assessment tools may be used. For example, examination is a technique in which a question paper in science theory and a question paper cum viva in science practical are used as tools for collecting information. 4.4.1 Theory. As C science teacher, you have to learn skills of constructing a good science theory question paper. You should note the following points in order to frame a good question paper. 1. The question paper should cover the whole range of topics mentioned in the prescribed syllabus. The coverage should not only be comprehensive but also well balanced by spreading questions on all significant topics and subtopics prescribed for study. 2. No question or part of question should be set which is outside the syllabus. 3. About half of questions should be set to test higher abilities such as comprehension, application of knowledge and development of skills, numerical and diagrams. For this purpose, the questions should be in the context of new situations rather than to ask routine or stereotype questions. 4. Wherever possible, the maximum length of expected answers should be prescribed. Terms like write short notes on, discuss, or what do you know about should be avoided as they do not provide clear direction to the students regarding the scope and length of the answers. 5. The language of questions should be simple and within easy grasp of the students. It should also be clear-cut and specific in regard to what is required of the student, i.e. a question or any part of it must not admit of more than one possible answers. 4.4.2 Practicals. Techniques of assessment in science practical are different than those in science theory. Usually, students in classes 9, X, 11 and 11 are assessed in science, physics, chemistry, biology, in practical skills. Here, out of several experiments, according to syllabus, students are asked to perform few L, 2 or 3 in each subject, physics, chemistry, biology. Oral questions are also asked on the experiments to get their theoretical understanding. Since Students do not perform all practicals on the examination day, therefore remaining experiments not given in the practical examination are to be assessed by the practical notebook of the students, in which they record all the experiments done by them during the year. Generally, 9, X and 11 science practical examinations are internal, X class. Marks in science practical examinations are to be sent by the schools to state education boards. In class 12, science, physics, chemistry, biology, practical skills are to be assessed by the external examiners appointed by the state education boards. So you, as a science teacher, internal or external examiner, have to assess science, physics, chemistry, biology, practical skills of students in classes 9, X, 11, 12. Therefore, it is essential for you to learn techniques of assessment in science practicals, evaluation of learning progress. While conducting science practical examination, assessment is done by observing of skills the students in performing practicals, asking oral questions, viva, to assess the knowledge of students on theory of experiments, construction and working of apparatus, examining students' practical notebook to assess their ability to record and process data. 4.5 Construction and administration of test. As a teacher, you have to construct and administer tests. Then, you have to mark the tests and analyze the data, marks obtained by the students. When administering the test, care should be taken to avoid copying by students. For this, invigilators have to be strong and tactful. Another way to reduce copying is to use objective type items and change the order of questions in every paper. In 4.4.1, you learned the qualities of a good questions paper. Taking those into consideration, follow the given steps while constructing test and also use the criteria of a good test. 4.5.1 Theory. When you plan to a science theory question paper, you should follow the following steps. In test construction 1. Steps in test construction. Identify the content, unit and subunit to be tested. Give weightage, marks, to each unit or subunit. 2. Identify abilities, knowledge, K. Comprehension, C. Application, A. Skill, S. Analysis, N. And synthesis, SN, and decide weightage, marks, to be given for each ability. 3. Identify various types to test items. Very short answer, VSA, objective, 2000, short answer, SA, and long answer, LA, and also decide number of items of each type, of weightage, marks, to each type of test items. 2. Louis rint DF the test. The blueprint is a table which depicts the design of test and have details about allocation of marks for the content areas. 3. Allocation of marks for the abilities to be tested. 3. Allocation of marks to question types. Study the sample blueprint. Set up a question paper with the help of the sample. This will give you some practice in setting up a question paper. You will also learn how a blueprint facilitates to set up a balanced question paper. 3. Framing questions. The blueprint is the guide for framing questions. It involves the technical competence of the teacher as indicated in the blueprint. Each question should be framed to test a particular objective. Content of be translated in objectives, desirably in terms of behavioral objectives, using the relevant content of the unit or subunit. Some sample questions in physics, chemistry and biology are given below for your guidance. Physics 1. What is the value of the absolute zero of temperature on a Celsius scale, VSA? 2. An object located 15.0 centimeters from a converging lens of focal length 10.0 centimeters produces a real image 5.0 centimeters from the lens, b real image 30.0 centimeters from the lens, c Virtual image 25.0 centimeters from the lens. D. Virtual image at infinitive. 3. Why does an egg sink in water but float in saturated salt solution? SOE. 4. How will you find out the velocity of sound by resonance apparatus? LA. 4. How would you prepare one I.S in laboratory? Write down its physical and chemical properties. Biology. 1. Name the part of the leaf through which most transpiration take place. VSA. 2. Which of the following organs is derived from ectoder tilde n? 0. A. Brain. B. Kidney. C. Liver. D. Heart. 3. Give 3 differences between aerobic and anaerobic respiration. SOE. 4. Assembling the question tilde s. After framing questions they should be grouped together according to their types. Very short answer. VSA. Questions may be kept at one place. Objective type. 0. At another place. Short answer type. SOE. At the third place and long answer type. LA. Separately. You can arrange them content-wise, ability-wise, question type-wise, as shown in sample blueprints. For practice, assemble the above 11 questions. This may be a form of a science question paper. Try and prepare a blueprint of this science paper. 5. Preparing instructions. Instructions are meant for directing the students to attempt the question in a particular manner. They go as a part of the question paper. For example, for the above paper, you have to attempt all questions. 2. Questions paper has 3 sections viz. Physics, chemistry, biology. 3. Questions number 2 in each section is an objective question, carry 1 mark each. 4. All SOE questions carry 2 marks each. All LA questions 10, 12 carry 5 marks each. Criteria of test. When framing a test question paper, the following criteria of a test should be taken into consideration. 1. Validity. A test is said to be valid if it actually tests what it intends to test. 2. Acceptability. The test should be acceptable to the candidates, otherwise it will not evoke the helpful and informative response desired from the candidates. 3. Reliability. A test is said to be reliable when even on administering several times, the same result would be given by a particular pupil or a group of pupils. You will construct a good test question paper if you take these criteria, validity, acceptability and reliability, into consideration. In 4.5.1a, in Section 4, assembling the questions, you were asked to assemble the I1 questions from that you got a small science theory paper. Administer this test on pupils and find out whether it has all the 3 criteria of a test: validity, acceptability and reliability. 4.5.2 Test construction. Some samples. In 4.1 you learned 5 steps in test construction. What are these steps? What are the advantages of those steps? 11 sample questions of 4 different types, VSA, 0, SOE, LA, were also given, from which you were asked to make a science theory paper. You were also asked to see whether these II questions in the test paper fulfills all the 3 I criteria of a good test: validity, acceptability and reliability. In these 1 question paper test, there were only 3 objective type test items which would of different types: true, false, fill in the blanks, matching and multiple choice. Out of those multiple choice test items are most difficult to construct because it requires objectively made. Multiple choice test items are widely used in admission and recruitment test. These test items are helpful in discriminating the able ex-es from the less able. You can also use multiple choice question to test the elementary child. In writing these test items, you, as a teacher, will have to develop the test material which do not have trivial, rote recall answers. Now, For your guidance, some sample multiple choice test items are give 11 here in physics, chemistry and biology from all the 6 cognitive domain objectives: knowledge, comprehension, application, analysis, synthesis and evaluation. Sample multiple choice test items. Knowledge, physics. 1. A ray of white light is broken up into a spectrum by a prism of colorless glass because A. The angle of incidence exceeds the critical angle. B. White light from an incandescent solid produces a continuous spectrum. C. The amount of refraction differs for light of different wavelengths. D. The glass absorbs certain frequencies and not others. E. White light is made of photons. Chemistry. 2. Organic compounds which contain oxygen include all the following except A. Acetic acid. B. Formaldehyde. C. Methane. D. Acetone. E. Ethanol. Biology. 3. The organ of the human body that secretes a hormone as well as digestive enzymes. For fats, protein and starch is A. Liver. B. Gallbladder. C. Pancreas. D. Intestine. Biology. 9. An animal breeder crossed a black and white guinea pig and a litter of 3 black offsprings resulted. The breeder concluded that the black parent could not have been heterozygous hybrid for cat color because he thought that any cross between a black heterozygous guinea pig and white guinea pig would yield a ratio of 1 black to 1 white offspring. His conclusion was unsound because he failed to realize that A black parent may have been a male. B. Mutatio tilde is in coat color frequently occur. C. Coat color in guinea pig is not inherited. D. Black coat color is dominant over white in guinea pigs. E. Genetic ratios are realizable only for large numbers of offsprings. 6. Analysis, physics. 10. Galileo investigated the problem of acceleration of failing bodies by rolling balls down very smooth planes inclined at increasing angles. From the date obtained he extrapolated oft case of free fall. Which oft following is an assumption implicit in the extrapolation? A. Air resistance is negligible in free fall. B. Objects fall with constant accelerations. C. The planes used were frictionless. D. Ply acceleration observed with inclined planes is the same type that is involved in free fall. 1L. E. A vertical plane and one which is nearly vertical have about the same effect on the fall. Biology. 12. In an experiment in which an empty tube of semipermeable membrane sealed at both ends was filled with iodine solution and placed for 30 minutes in a beaker of starch solution that is normally white in color. The iodine solution inside of membrane remained reddish-brown. The starch solution in the breaker turned blue-black. A. Iodine is a disinfectant. B. Starch molecules are bigger than iodine molecules. C. Iodine is necessary for starch digestion. D. Starch turns blue on adding iodine. V. Synthesis. Biology. 15. You are to conduct an experiment to determine whether the rate of photosynthesis in aquatic plants is affected by the addition of small amounts of carbon dioxide to the water in which the plants are growing. You have the relevant apparatus and healthy Hydrilla plants with you. If the addition of carbon dioxide were to have an observable effect on the rate of photosynthesis in aquatic plants, almost immediately after increasing the amount of this gas in the water, you would expect to observe a noticeable change in the A. Growth of the plants. B. Temperature of the water. C. Coloring of the plant leaves. D. Rate of bubbles produced by the plants. E. Amount of oxygen consumed by leaf respiration. 6. Evaluation, physics. 16. If a rocket is moving away from the surface of the Earth fast enough, its speed would offset the pull of gravity and a mass in the rocket would feel weightless. This statement is A. accurate since two forces are involved in this situation and two forces can offset one another. B. Accurate since the weight of an object decreases rapidly as the distance from the center of the earth increases. C. Inaccurate since the floor of the man's compartment will be pushing up as the rocket rises, and the push will give a feeling of increased rather than decreased weight. D. Inaccurate since the chance that the force on the man due to the rocket moving up and the force of gravity pulling the man down will be equal is extremely minute. E. Inaccurate since no object within the gravitational field of the earth can be weightless and so cannot secure weightlessness. Chemistry. 17. Analysis by weight of a certain compound shows that it contains 14.4% hydrogen and 86.6% carbon. Which of the following is the most informative statement that can properly be made about the compound on the basis of the data? A. It is a hydrocarbon and evaluation in science. B. Its empirical formula is CH. C. Its molecular formula is CH. D. Its molecular weight is 28. E. It contains a triple bond. Biology. 1.8. Which of the following procedures would give the most convincing result as a test of whether or not a new drug would be effective in curing cancer in mice? A. Injecting the drug into a large number of mice with cancer and comparing the number of mice who are cured without any treatment. B. Injecting the drug into mice with cancer and reporting how many of those mice are cured of cancer. C. Injecting the drug into mice with cancer and reporting how many of these mice are cured of cancer. D. Injecting the drug into a large number of mice with cancer and injecting the same amount of distilled water into an other large number of mice in each group who die of cancer. E. Injecting different doses of the drug into a large number of mice with cancer and reporting the number of mice that are cured in each group. 4.5.3 Practical. Arts Science Practical Examination. All science subjects, physics, chemistry and biology, have two parts, theory and practical. So far, we have discussed test construction in theory. Although practical are not the component of examination at elementary level, but still they are important to be learned. Usually in science examination, some practical exercises are also given to be completed in the given time. The teacher or the external examiners observe the students when they perform these exercises. They also ask some viva questions. Some education boards also set papers for practical examination. These papers also accompany list of apparatus and chemicals required in science practicals and 2 general instructions for examiners. This helps external and internal examiners for smoothly conducting the practical examination and evaluation the students on their practical skills. As a science teacher, you will also be involved in conducting practical examination. You may also work as an internal or an external examiner, or you may be assigned work of paper setting for a science practical examination. For your guidance, the following material as sample is given here. A. Test paper. B. List of apparatus and chemicals required in science practical. C. General instructions for examiners in science practical. And D. Key to the question paper in science practical. Note: this material is for secondary school 9x examination in science practical, physics, chemistry and biology. Similar material can be prepared for senior secondary 11-12 examination in physics, chemistry, biology practical. E4.6 Monitoring of learners' progress. When you teach science theory in the class and practicals in science laboratory, you monitor the learners on the basis following interaction, either in class or laboratory. 1. Teacher-learner interaction, 2. Learner-teacher interaction, and 3. Learner-material interaction. On the basis of the interaction, you categorize the learners into above average, average, and below average. If you start interacting with below average, they can also become average and then above average. This means positive interaction must. If you just encourage the above average, they will start doing self-learning and can become outstanding. Thus, everyone below average, average and above average will progress. Thus, monitoring is a very strong tool of learners' progress. If you do not monitor your learner, they will remain as they are, with no progress. You also monitor the learner's progress by taking written tests and practical examination, as well as by examining their practical record in their practical notebooks. Written tests may be in a form of a unit test, weekly test, monthly test and terminal tests. Assessment of all such tests will facilitate you to monitor learners' progress. Homework, project work and field work also help you in monitoring of learners' progress. By monitoring, you will know where the learners are weak, and when you will apply different techniques, you will remove their weakness and they will progress. 4.7 Diagnostic tests and remedial measures in science. When you teach science in a class, you ask questions before you introducing the topic. These questions test previous knowledge of the learner. Unless children have this previous knowledge, they will not understand what will be taught in the lesson. Thus, questioning is a type of verbal diagnostic test which you use before starting the lesson. This test assesses what the children do not know. So, before starting the lesson, the teacher teaches some precursor material so that children will be able to answer the unanswered questions. After that, teacher starts lesson and then children do not have much problem in understanding the lesson. Teaching of this precursor material is a type of remedial measure. So, teachers always do diagnostic testing and remedial measuring when they teach science in the class. But it is not always possible to do justice to the lesson by simple informal questioning. The teacher needs structured evidence. Tests, verbal or written, are given to the children. This type of test is called diagnostic test. Analyzing the responses of the children on the test, the teacher knows where the children are lacking. For that, he takes necessary remedial measures. For example, when children come to the class 9 after passing class 8, the science teacher has to know whether his students have the previous knowledge which they had learned in science in middle or upper primary classes 6, 7, 8. To find it out, the class 9 children should be given a diagnostic test which covers the previous knowledge for 6 Willy science classes. This will help 9 and X class science teachers to know whether students lack and can take some remedial measure. Similar is the case when children come to class 6 after passing. So, while preparing a child for 6 diagnostic test based on whatever has been learned in IB science classes, this will help 6-7 class science teachers to take some remedial measures to give a similar diagnostic test in science in the beginning of each class will be ideal, and if the concerned science teachers take necessary remedial measures, the children will understand and enjoy science. 4.8 Summary. After content and methods, evaluation is the next important step in teaching science. Examination is not really evaluation, it can be clubbed under assessment. Our examination question should cover all the objectives i.e. cognitive, affective and psychomotor. Clearly defined objectives help us in effective and objective evaluation. Our examination system has a big hand in ensuring continuous and comprehensive evaluation. Evaluation is much More than merely the examination, examination is assessment. Evaluation stands to assess all the educational outcomes, cognitive, affective, psychomotor, science curricular and co-curricular activities. Both assessment and evaluation have their OW11 importance. Evaluation in science assesses all the teaching learning outcomes in terms of overall behavioral changes related to science content and science process. The purpose of evaluation is to assess the overall development of child. Observing and questioning are two main teacher activities for and evaluation in science assessment. A good assessment program depends upon the appropriate and accurate evidence that we get about pupils' growth. And assessment tool is an instrument which facilitates assessment work. An assessment techniques is a process of gathering information or evidence in which one or more than one assessment tool may be used. As a science teacher, you should know how to set a good science question and also the qualities of a good question paper. When setting a science theory question paper, you should know and follow the criteria of a good test, validity, acceptability, reliability, and steps in test construction, designing of the test, blueprinting of the test, framing questions, assembling questions and preparing instructions. There are various types of objective tests in which multiple choice type, if constructed objectively, are very popular and useful. You should have enough practice to construct multiple type test items in science, physics, chemistry and biology for all the abilities in cognitive domain knowledge, comprehension, application, analysis, synthesis and evaluation. Besides multiple choice test times, you should also practice other objective tests as well. Very short answer, VSA, short answer, SA and long answer, LA questions. As a good science teacher, you should also know and practice monitoring of learners' progress as well as diagnostic tests and remedial measures in science. As a good science teacher, you should also be a good science evaluator. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.